Welcome to this Process Insights guided wave video describing features of the OmniView for 508 software. In previous videos, we've shown you how to configure the analyzer. We've shown you how to take 0 scans on the analyzer. And also, we've shown you how to take scans on demand. Now that we can produce spectrum, what do we do with it? What can you do with the spectrum to produce a meaningful result? And to do that, we're going to look at the prediction methods screen. This screen contains the definition of method scripts that have been written to analyze data from the spectrum. On the left side, we have a list of method scripts that have been written. We have buttons for adding and deleting them. We have a select button where you select the channel that you want the scripts to run on. We have the name of the script. We also have this editable area where you can add or modify the script. Method scripts in OmniView are Python scripts. As part of the software installation on the computer, we have installed Python. We've also added a library of functions written in Python for manipulating the data. What I want to do in this video is show you how to write very simple Python method scripts. So we're going to start by clicking the Add button. And I'm going to provide a name. I'm going to call this one Demo 1. I want it to run on channel 1. I'm going to uncheck this box. I don't want this script to run yet when we take scans. We'll turn that back on in the future. As a starting point, I'm going to write the simplest script possible. So in this script, we're simply going to set a variable called answer equal to a numeric value. In method scripts, the variable answer, spelled just like it is here, is a special variable. Method scripts have to set this variable answer to a value in order to be of any use in the OmniView system. It holds the result of a method script. We're going to add this method to our list. You'll see it come up in our list now. And you can see the script that we have here. Now, again, this is editable. I can change the script here if I want. But for right now, I want to show you how to test run the script. So I'm going to click the test run button here in a second. What this is going to do is it's going to go get the latest scan from the channel, and it's going to provide that scan as input for this method script, and then it's going to execute the script. Now, the script is set a variable called answer equal to 1. So that's the simplest script possible. If you fail to set answer in your script, you will see the following. Pass, by the way, in Python is simply a command that it's a statement that it's like a no operation. So I'm going to save the changes and I'm going to click test run, and we get an error. We get a Python error. Okay, you get an error because the software is looking for a variable called answer which does not exist because we haven't set it. Your script must set answer. So let's expand on this script. Let's make it actually do something. I will show you how to pull out an absorbance value from the spectrum at a particular wavelength. Let's go look at our spectrum, and let's say we are interested in the absorbance at this peak. Okay, I just held the control key down as I moved the mouse slightly, and it's centered on that point. We're interested in the peak at wavelength 416.5. We are going to set answer equal to the result of another library function called getAU at. This function needs as input as its first argument, the ID of the scan. So we will provide the reserved word, or the reserved variable name scan. And the second argument is the wavelength at which we want the absorbance. So that's a floating point number, 416.5. So let's save the changes and test run it. What this has done is it's computed the index of where wavelength 416.5 occurs in the spectrum, and then gone and gotten that value. And to check that, let's again go look at the spectrum. So remember that number, 0.4, it's almost 0.49. Let's go back here, and we'll look at that peak again. And there you can see the absorbance value is 0.49. Let's expand on this script, and this time we're going to do it by adding some code from the special little library that we've provided. We have a few scripts completely written and made available for you as starting points for writing your own scripts. What we're going to do is we're going to grab this script and we're going to replace our script with the contents of this library script. Let me explain what this script does. So this script gets the absorbances at a couple of different wavelengths and then applies coefficients to them to come up with a number. So we're going to pretend that somebody's done a multivariate analysis of this spectrum and determined that some result that they're interested in can be obtained by finding the values at a couple of different places in the spectrum and applying these coefficients and this offset to them. And since we're just kind of making this up as we go, I really don't care what the values are, so we're going to use their wavelengths of 208 and 213, which if you go look over here, 208 and 215 are over here in this region where we're not really getting good values. This is just for demonstration, so we're going to go with it. Some analysis has determined that these coefficients applied at the absorbances at those wavelengths gives them a meaningful value. Let's look at this line by line. We're calling a function called getAU. Notice it's not getAU at, but it's getAU from the scan. Remember, scan is a reserved variable name where we provide the ID of the scan where we can go look it up in the database. And this function returns an array. So the variable AU is not a single number, it is a list of values. Similarly, getWL returns an array containing all of the wavelengths represented in the spectrum. And getAU and getWL will each return an array that's the same length as the other. So there are the same number of values in the wavelength array as there are absorbances in the AU array. Now, we're going to use another library function, which is similar to the getAU at, in that it can compute, given a wavelength and given the list of wavelengths in the spectrum, can compute the index at which that wavelength occurs. So wavelength index of wavelength 208 in or from the wavelength array that we have, it returns an index. It's simply an integer value which is an index into these arrays. So we get the index for wavelengths 208 and 213. Then we use those two indexes to go get the absorbances at those wavelengths. And we're putting those values into two variables called AU208 and AU213. Then finally, we're applying these coefficients to the absorbances at those two different wavelengths. And then we're adding an offset and we're coming up with a number. So let's test run this script. It runs and it produces a number. So in this video, we have demonstrated that you can use the spectra produced by the analyzer to produce meaningful numbers. The contents of each method script are Python scripts, which we execute at runtime. Remember, let's demonstrate how it works by putting the method online. Now that this method is online, every time we take a scan, we are going to run this script, and scan will have the integer ID of that scan that we just took, and we will get values. So let's go try that. I'm going to save the changes. I'm going to go out to the scan screen, and we're going to take a demand scan. Okay, it took one scan. Let's take a few more. There's 2, there's 3, there's 4. Theoretically, we've just taken 4 scans and run that script 4 times and come up with 4 different numbers. We will cover the answer screen in our next video, but let's take a quick look at it and go select our method script from this list, and there we can see the 4 values that were just produced by taking demand scans. And let's show these values in a table. There's the 4 values. We will make other videos about other aspects of script writing, and we will also make a video on showing you the answer screen. Thank you for watching.